All right, so we're going to look at 3 different sections this week. We're going to look at 5.1, and then we're going to jump to a section in the back of the book. Again, that's called A4, Appendix 4. And then we're going to come back and do section 5.3. All right, so this first section is on what we call polar coordinates. It's basically a different way to write a coordinate other than using x, y. There's an example of a polar coordinate. And the first thing we're going to learn how to do is, how do you take that and graph it? Just like basic coordinates. What do you do? Where do you put the dot for 3, 120 degrees? Well, this is the kind of graphing that we've pretty much focused on this year. Okay, this is called a Cartesian coordinate system. It has an x and a y axis. And usually you give 2 numbers like 2, 5. And if you want to graph it, it means write 2 up 5. Yeah, write 2 up. The kind of coordinate system we're going to look at this week uses, well, you can see what the grid looks like there. That's called a polar graphing system. It's a little bit different than Cartesian. And one thing that polar is really good for is drawing circular shapes. It's very, very simple to draw a circle. Let me show you how you would have to type in a circle on this kind of system, okay, the system you're used to. First, I need to just pick what size circle. Let's say I wanted to do a circle with a radius of 3. That's the equation of a circle. What I'm really trying to show you here is you're going to see how complicated it is under a Cartesian system to draw a circle and how simple it is to do it on a polar system. It's very, very easy. Okay, so first of all, I said I'm going to pick a number for the radius. I'm going to make it 3 units for the radius. So my equation is going to be x squared plus y squared equals 9. Now, if I want to put that on the graphing calculator, what letter has to be by itself? What letter? Yep, y, right? When you go to graph something, it's always y equals. So I have to get the y by itself if I want to type in that circle. So I can subtract it to the other side. And then I have to get rid of that exponent of 2 by taking a square root. And remember, when you take a square root, you get 2 answers, a positive and a negative. So let me type that in. This is pretty complicated. Right? It's not a very simple equation. It's not like huge, but it's still not super simple. So the square root of 9 minus, how did I get exponent? Sorry, you did the wrong one. This would be, there we go. So I did what Dustin said, not what Ryan said. What Ryan said, that was correct. Get y by itself, not x. Okay, so I've got y by itself. Now let me type that in and see what it looks like. So the square root of 9 minus x squared. Okay, does this look like a circle? No, it doesn't. Let me do zoom 6. Okay, and then zoom 5. Okay, does that look like a full circle? No, I only got half of it because I didn't type in the negative part. So let me type in the negative square root of 9 minus x squared. And that's the best I can do. It doesn't even quite connect. Right? But I cannot draw a circle using y equals notation any better than that. It's the best I can do. And I didn't even really draw a circle. I drew the top half and I drew the bottom half separate. So we had to type in all of this stuff to get a picture that doesn't even really completely connect and look like a circle. I mean, it kind of looks like a circle. But that's all you could do. Now, let me show you how this would look in polar. If I change the mode on my calculator to polar, watch what happens. It doesn't say y equals anymore. It says r equals. Let me put in a 3 and hit graph. I didn't set my window. Let's do zoom 6. And now zoom 5. There. Don't worry how I set my window. I just want you to see that now I get a picture that looks actually like a circle. It actually connects. And all I had to do was type that, to get that, was type in one number, 3. So graphing a circle is much simpler in polar in terms of the amount of stuff you have to type in. Now, we don't even get into really graphing, not that I would call this fancy, but even equations like that. All we're going to do is be graphing single points. When you put a bunch of points together, that's when you get a picture. But what's kind of neat about polar is you can graph things that you wouldn't even be able to imagine seeing on an XY axis. You could do something like this. Watch what this looks like. Let's try that. So there's a polar graph that there's no way you could ever draw anything like that at all on an XY axis. So totally different looking. Could also draw something like, let's try this. And let me zoom out. I don't know if I can zoom out enough. Yeah, you're starting to see it. This is a spiral. There you go. So that's a spiral. And again, that's a graph that you couldn't draw in y equals notation at all. Can't do that. So polar graphing really opens up all kinds of new designs that we can do with graphs. But the most basic thing we have to learn first is just how do you do a single dot? Just one point. Never mind a whole collection of points. And that's what we're going to start with. Okay, how do you graph a point? So XY system, that's what we're used to. We're going to look at what's called polar form. Okay, the biggest difference in polar form is the graph paper doesn't use like a rectangular or square grid. It uses concentric circles coming out. And there's usually radial lines drawn on those circles, like this one. Now, instead of calling it the origin, I mean, you could still call it that, but a lot of times they call it the pole. And the horizontal, they call that the polar axis. And in polar, it's going to rely on an angle. Okay, so we have degrees going around the circle, starting at 0 on the right, 90 at the top, 180 on the left, and 270 at the bottom. And the idea here is not move left and right and then move up and down. That's an XY axis point. The idea with this is you're going to move out a certain distance from the origin, and then you're going to rotate a certain number of degrees. Whether you're going to rotate clockwise or counterclockwise, well, it depends on whether your angle is a positive or a negative. We'll look at each case. So polar coordinates are still written with 2 numbers, and I showed you guys one earlier. But they're not x and y. That's not what the 2 numbers stand for. The 2 numbers stand for r and theta. What do you think r means when we're talking about graphing on a circle? Yeah? Radius. Radius. It's how far out from the origin do you go? So r is your radius. And theta is a Greek letter. What do we usually use a Greek letter for?
Degrees.
Degrees or radians, which is Well, what does degrees and radians apply to? What kind of quantity? Is it length? What's a degree or radian used to measure? An angle, yes. So it could be degrees or radians, but the second number after the comma is an angle. So how do we graph a point if they give you like 4, 90 degrees? What would you do? Well, this is what you do. The first thing is R is kind of like it's kind of like an X number. It's how far out you're going to move from the origin, or the number of rings you're going to move out. If R is a decimal, you may end up in between 2 rings. Just like X and Y values, the first number can be positive and negative, and the second number can be positive or negative. If R is positive, you're going to start out from the pole, which is the origin, and you're going to go to the right, the number of units that's given to you. So if it was like 4, and then they had an angle right here. First thing you would do is start at the origin and go 4 units to the right. What do you think you'd do if R was less than 0? You'd go to the left. Now, that's not the final answer. That's just where you're going to start from now to do a rotation, either clockwise or counterclockwise. So move out the number of rings indicated by R. If it's positive, go right. If it's negative, go left. So the second number represents an angle. And I might have already said it, but what are the 2 directions you can move on a circle if you're rotating? Clockwise or counterclockwise. How do you know which one you do? Well, it's going to depend if the angle is a positive or a negative. So if your angle is positive, positive means to go counterclockwise. Positive angle means to go counterclockwise. That's counterclockwise. If your angle is less than 0, doesn't matter if it's a degree or a radian, if it's less than 0 and it's a negative number, what direction do you think you would go? You're going to go clockwise. That's clockwise. So kind of like graphing an XY point, but it is a little bit different. You start by either moving left or right, and then go clockwise or counterclockwise. All right, so we're just going to try lots of examples with every kind of case that you could have. All right, let's start with this one. Okay, so first thing we want to make sure is we know which one is R and which one is theta. What's my R in this case? 3. And that means that is the angle. So don't worry about the angle yet. Start with R. What way am I going to go starting from the pole? And how many units am I going to go? I'm going to go right 3. 1, 2, 3. That's not the answer. I'm going to erase that. I just put a temporary mark where I'm going to start my rotation from. So I started by going right 3. 1, 2, 3. And how many degrees does it say to rotate from where I put down the legs? 120. And Curtis, which way does it tell me to rotate? Counterclockwise. Now, on this grid, there's a line every 15. This is 15, 30. All the red ones are your 45s. 60, 75. So I've got to rotate 120 degrees counterclockwise. Well, I know I got to go at least 90. And then how many lines past 90 do I have to go to get to 120? 2, because each one is 15. 2. So that point that I just drew, that's how you graph the point 3, comma, 120 degrees. That's the answer. Questions on, yeah?
Is it degrees always going to be a whole number is like 15?
I mean, I guess it could be like 100, and then you'd have to put it in the middle. Or this number could also be like 3.5. If it was 3.5, then you just put it right there. So you're in between the third and the fourth circle. I would say most of the time it'll be a multiple of 15. Yeah. It doesn't have to be. Yeah, let's try this one. What's different about this coordinate? Yeah, it's in radians. So if you can graph it in radians, then you can just do it. If you're not comfortable with radians, then you might want to change to degrees. Okay. Sam, how do I change pi over 4 radians to degrees?
You multiply it by 180 over pi.
Multiply by 180 over pi. Pi's are going to cancel. And all we're left with now is 180 divided by 4. And Kiana, what is 180 divided by 4? Yeah, 45. So essentially what you're graphing here is 5, 45. Okay, let's go through it. Alex, what's my radius in this case? 5. And Tony, it says to move 5 units. Which way? To the left or to the right?
To the right.
To the what?
Right.
To the right, yep. So we're going to go. Okay, that's not the answer. That's just where I'm going to start from. From that point, Cameron, how many degrees am I going to rotate? 45 degrees. And Fiorella, which way am I going to rotate? Clockwise or counterclockwise? Counterclockwise. 45 brings me up 15, 30, puts me right there. So that's the point 5, 45 degrees. Okay, questions on that? Try another one. All right, so now we've got negative angle. Same idea, it's just going to change the direction of rotation. Okay, so 1. What's my radius in this case?
5.
Yep, the radius is 5. So we're going to start at the pole. We're going to move 5 units. Gavin, which way am I going to move from the pole? I know I'm going 5 units, but 5 units which way?
5 units to the right.
5 to the right. 1, 2, 3, 4, 5. It's kind of just like an x coordinate in that case. So 5 to the right. Ryan, how many degrees am I going to rotate?
210.
I'm going to rotate 210, but I need to go clockwise. So if I go all the way to here, how far have I gone?
180.
Gone 180. How much more do I have to go to get to 210?
30.
30 more. That's 2 sections on the circle. So you go right 5, and then you rotate 210 degrees clockwise. And that's how you graph 5, negative 210. Any question on that? Okay. Let's try this. Negative 3, comma, What's pi over 2? We just did pi over 4, so this is double. This is 90. Negative 3, 90. So, Naija, what's my radius?
90. Oh wait, your radius is negative 2.
Well, what way am I going to move from the origin?
To the left.
To the left, yeah. So the radius, yeah, so it's going to be 3 units, but it's to the left because it's negative. So 3 units left. 1, 2, 3. And Tyler, how many degrees am I going to rotate from there?
90 degrees.
90 degrees? Which way?
Clockwise. Right.
Well, that's a positive angle.
Yes.
Which way do we rotate if the angle is greater than 0? Counterclockwise or clockwise? Counterclockwise. Yeah.
Or, so 1, 2, 3.
Yeah, it's going to be at the bottom. Good. So it's going to be counterclockwise. And let's draw it. So we went left, and then we went counterclockwise 90 degrees. What's a different way we could get to that point? Besides negative 3, comma, positive 90.
3, negative 90.
So we could do 3, negative 90, and that would look like this. Right 3, clockwise 90. So there's a second way.
Keep going all the way around.
Okay. So what would be a third way?
3, 270.
So 3, 270, that would mean right 3, and then rotate 3/4 of the way around in that direction. Looking for a fourth one. So we've got a negative, positive, positive, negative, positive, positive. We're missing the negative, negative. Yeah.
Would be negative. Negative 3, negative 270.
Let's try it. So negative 3 means go left 3. And now negative 270 means to go clockwise 270 degrees. And that's pretty much it. So what that shows us is if you're graphing a point in polar, there are up to 4 different ways to get to it. Sometimes there's only 3. Like if you land on one of the other polar, like if you land on the polar axis, there might only be 3 ways to get to it. But if you land on anywhere except the horizontal axis, there are always 4 ways to get to it. Sometimes 3. Now, let's compare that to something like this. If I want to get to this point right here, how many ways can you write a coordinate that gets me exactly to that dot?
Just one.
Just one. So in a rectangular coordinate system, there's only one way to get to a point. In polar, there's up to 4, sometimes 3. There's more than one. Now, I don't count going around the circle more than once as a different way. Like if you go right, and then say go around, 3 times, and then stop. Well, that's still going right, and then just going counterclockwise. That doesn't count as a different way. Otherwise, there'd be thousands of ways. So 4 basic ways are right clockwise, right counterclockwise, left clockwise, left counterclockwise. Those are the 4 ways. Any question on that? Now, the point of that is I wouldn't have you write an answer 4 different ways on the test, but if it's a multiple choice question and I ask you what the answer is, maybe you got something like this as the answer, and I decided to write positive values for the answer. You'd have to know these two things are the same. Easiest way I think to do it is just to graph. You can try to come up with formulas, like, okay, if I have this one, I can just add 180 and then make this number the opposite, and it works. But that's a lot of stuff to remember. The easiest way is just draw it. Okay, let's try this one. -2, -180. All right. Well, Dustin, what's the first thing I'm going to do here?
You can move to the left 2 units.
I'm going to go left 2. And then we're going to go 180 degrees which way?
Clockwise. So you can go up.
Yeah, so it's kind of like going up.
You're gonna end on the line.
Now, if I had done, I can just put that like that so you can see that. If that was a positive 180, how would my answer change in terms of where I end up? It wouldn't. Well, if it's positive 180, that means you just go this way. Negative 180 or positive 180 would still land you in the same spot. If you wanted to land over here, which is on the opposite side, you could just make this angle what?
360.
You could, and 360 is the same as. What's 360 the same as? I'm in degrees. 0. If you made this angle 0, that means don't move at all. We're going to talk about 0 in a second. But if this angle was a 0, you just go left 2 and then you're done. There'd be nothing else to do. All right. So let's look at ones with zeros. Yeah, what's my radius? 0. So I'm going to be, right at the pole. But I'm going to rotate how many degrees? How many degrees?
300.
Yeah, I got to rotate 300. So what you want to do is you put your dot there like that. But then you want to rotate it like this. It's 270, 300 right there. That's what you do. And the way I can tell, when I had tests on paper, I could tell like if people put their pencil down, I look for what I call the spin factor. So if I didn't see that, then I know you didn't rotate it. So you got to rotate it. But yeah, it doesn't matter. Like someone said with Tyler or back there. No, you had said it earlier. It doesn't matter what the angle is because if it's 0, you're just going to rotate in place. So 0, anything is right at the origin all the time. How about 1, 0? Is that going to be at the origin? No, where's that going to be? Just write 1. In general, if you have a number, but your angle is 0, you're always going to end up on the polar axis. You're either going to go left if it's negative, right if it's positive, and then stop, because there's no rotation. So that covers pretty much every type you could have. Positives, negatives, and zeros. Any question on those 7 examples we've done so far? Now, one thing I didn't mention, I wanted to mention. I showed you how simple circles are in this system. What do you think ends up not being very simple in this system? What is it? No, not a transformation, more of a shape. There's a shape that normally is pretty simple to draw, but it becomes extremely complicated in polar. Yeah?
Square.
No, a shape that you would do in Algebra 1. We don't really have a formula to draw squares and rectangles. Even simpler, yeah? Off the top of my head, I don't know how complicated an oval would be. It's kind of related to a circle, and circles are pretty simple. So I think ovals might not be too bad here. But yeah?
Triangle?
We don't really graph triangles because we don't have like a formula you can type in on a calculator and a triangle appears. But what else do we draw a lot on calculators? Yeah, lines. Lines are very simple to draw in this system, right? I think the most common way people do it, y equals mx plus b. That's the best equation we can use, and that's the best system for it. If you want to start drawing lines on a circular grid, well, now we need to involve sines and cosines just to draw a straight line. It becomes very complicated. So ideally, you don't want to use this system for lines. All right, so let's take a look at this point. 3 comma pi over 6. It's probably going to be easier to think about it in degrees. What's pi over 6 in degrees? Yeah? 30. Because pi is 180. So it's 180 divided by 6. Okay, so what do I want you to do with that point? I want you to write this point different ways. We just practiced that a couple problems ago. First way I want you to try to write it is with a positive radius, but I want an angle between 360 and 720. So think about what you could add to the angle to make yourself go around an extra time. That's what this is getting at. We're going around an extra time. Then I want to try to write the angle, write the point with a negative radius, but I want the angle between 0 and 360. That's one of the ways we practiced a couple problems ago. And the third way, we also tried this one. I want the radius positive, but I want to go clockwise to get to the point. Clockwise means I want the angle to be negative. So the easiest way I think to figure that out is to think about it visually. Point 330 is going to be right here. So looking at that graph, see if you can take a couple minutes and figure out 3 different ways to get to that same point. And those are the 3 different conditions that I want to have. Does everybody have those written? Okay, so I'll leave them up there for a second, and then what I'll do is I'm going to make the grid on the right bigger so people can kind of look at it and visualize what's going on, since you don't have a graph paper like that in front of you. Okay, so between 360 and 720 means between 1 and 2 times. Well, if you want the radius to be 3, or negative 3, because it has to be one of those 2 numbers, which one does it have to be this time to meet that condition?
3.
It's got to be 3. So we're going to start by going 3 units to the right. And then they want us to go around between 1 and 2 times. Which way? Clockwise or counterclockwise? Counterclockwise. So they want us to do this. And describe what that angle is. It's more than 360, but it's less than 720. How much is that angle? 390. So there's your first one. 3 comma 390. Would we normally want to write an answer bigger than 360? No, not normally. But in this case, they asked us to do it. Okay, how about the second one? This time they said the radius has to be less than 0. So what would it have to be? It's got to be negative 3. So you're going to start 3 units to the left. And now it's just a matter of which way do they want you to rotate to get to the point. Do they want you to go clockwise or counterclockwise? Counterclockwise, right? Because they want a positive angle. So positive angle is counterclockwise. Negative is clockwise. So counterclockwise is going to be this way. We have to figure out what that is. So we went left 3, and then how many degrees did I rotate counterclockwise? 210. I went halfway, and then I went 2 more sections. Each section is worth 15. So halfway is 180, plus 30 is 210. So that's a second way that you can write this point, and that's something you would probably more likely to see on a test. And the third way is ball. Okay. For the third way, they want the radius to be greater than 0. So what do you have to be on the third circle? 3 is the only option. So let's just move this. So we're going 3 to the right. 1, 2, 3. And then which way do they want us to rotate? Clockwise. So it's like they want us to take the long way to get to that point. So we're going clockwise. Well, because we went clockwise, we know it's what kind of number, first of all.
Negative.
It's a negative. And how many degrees did we rotate to get to that point?
330.
Negative 330, yep. Because this section right here, that's 30 degrees. We went all the way around, except we stopped before we went through that section. So 3 different ways to write the same thing. And how many ways did I say there are up to? Up to 4. Sometimes only 3. Okay, any questions on that? Okay, so we got that. All right, so last thing we're going to look at. And this is going to connect with the first thing we do tomorrow, except we're going to flip this around tomorrow and do it the other way. So this is how we convert a point from polar to rectangular. So first, I just want to think about, when you have a point in polar, what do you call the 2 things they give you? Radius and theta. And we're trying to convert it to a rectangular or Cartesian system. That's what you're used to. What do you call the 2 things in rectangular? X and Y. So when you are trying to change from polar to rectangular, you have to get rid of the r and the theta and somehow get an x and a y. Well, let's draw it and see what's going on. R and theta. R is how far away you are from the origin. It's the distance. So in this case, that's R. It's how far, it's basically how far out you moved from the origin. And theta is an angle. That's how much you rotated to get up to that point. So that's my angle. That's my radius. So the way that this person got to that point is they did this. Just put that on a circle. I don't know how many rings they went out, but however many rings they went out R rings, and then they rotated theta degrees. And that's how they got to that point. Now, X and Y doesn't have anything to do with rotation. It has to do with move horizontally and then move vertically. So what shape do you think we could make here to help visualize this X and Y?
Triangle.
Yeah, we're going to make a triangle. And the way we're going to do it is just like that. Now the X and the Y are in that triangle. What's the x? That's the base. X is how far you move from here to there. So that's my x. And what about my y? That's my height. That's the distance from here to here. So if you can figure out the base and the height of that triangle, that is how you change from polar to rectangular. You have to find the base and find the height. Okay. Let's start with the base. Okay. So I want to find that. And remember, the two things that they're going to give you, it's going to be in polar. So what are the two things that they're going to give me in polar? The radius and the angle. So let's look at x. Where is x in relation to that angle? It's adjacent to it. So this is adjacent. And where is r in relation to that angle? That's your hypotenuse. If we can figure out which trig function has adjacent and hypotenuse in it, it's going to help us to solve for the base of that triangle, which is the x value in the rectangular coordinate. So which trig function is it? Cosine, yeah. Okay, let's fill that out, and then we'll figure out our formula. Okay, cosine of what's the angle that I'm using here? Theta. Equals adjacent over hypotenuse. X over r. And the goal is to get a formula for x. So what would be in that box? R times cosine of theta. Multiply each side by r. R is on the right cancel. And this is the formula to convert a polar coordinate into an x value. You take the cosine of the angle they give you, and you multiply by the radius. So that's your x. And now we need to get the y. Okay, what position is that in? It's the opposite. Okay, so again, focus on what is circled. They're going to give you the r, they're going to give you the theta, and you're going to find the y. So what trig function involves opposite and hypotenuse? Yeah? Sine. So let's write that down. So the sine of something is going to equal something. Okay. Sine of what? Theta. And sine is opposite over hypotenuse. So in my problem, what's opposite over hypotenuse? Y over r. Yep. Again, the goal is to write a coordinate, so we need a formula for the y value. What's going to go in that box? R, multiply each side by r, and you're going to get r sine theta. This is the formula to convert a polar coordinate into the y value. So you need two formulas. One for the x, one for the y. And I think I wrote that same thing right here. Yeah. So converting from polar to rectangular. We basically already wrote this down. But if you're given a point with an r and a theta, you take the r and the theta and you plug them into these two formulas. And it'll give you the rectangular coordinate. R cosine theta and r sine theta. Now, what trig function didn't we use here that we use a lot? We didn't use tangent, and that's because tangent is going to go the other way. If we want to change rectangular to polar, we're going to use tangent. We'll talk about that later. Any questions on those two formulas? So I guess it's a new way to think about what we're doing, but it's not really new math that we haven't done before. We found sines and cosines, and we found bases and heights. We're just using the base and the height to write a coordinate. That's all. Let's try it. So it says to convert 6 comma pi over 6 to rectangular. As long as your calculator does radians, there is no need to change that to degrees. If I was drawing it by hand, sure, because I think in degrees easier than I do radians. But we're just going to type that into a calculator. Let's make sure we know which one is which. What's my r in this case? 6. And my theta? Pi over 6. So the goal is to convert that point into rectangular using those two formulas. It doesn't matter which one you do first. I usually do the x first, then I do the y. It doesn't matter. Okay, let's write it down. What's my formula for my x value? After I fill in the two numbers that they give me into what's in the box. So not looking for the final answer. We can use our calculator for that. I'm just looking at what would I type in on the calculator to get the x value for that polar coordinate. Yep.
Are you looking for x or?
Just the formula to find x.
For y you do.
No, for x.
For x, okay. You do r cosine to degrees, which would be 6 cosine pi over 6.
Yeah, that's all I was looking for. Formula to find x is 6 cosine pi over 6. Okay, I'll worry about that in a second. Now, what's the formula to find y? 6 sine pi over 6. Let's try that and see what we get. So, let me clear that. So 6 cosine pi over 6. Now, if I hit enter right now, I will get it wrong. How come? Because I'm in degrees and pi over 6 is not degrees. If that was a degree, you'd see a degree symbol. So what I'm going to do is just change to radians. I think it's easier to just change the mode on the calculator rather than do a conversion to figure this out. Just one more thing you could mess up. All right, so I'm in radians. I typed in 6 cosine pi over 6. And I get the number about 5.2. 5.20. And when I do the bottom one, 6 sine pi over 6, I get 3. Pi over 6 is 30 degrees. We talked about that earlier. Whenever you're dealing with an angle that's a multiple of 30, if you're taking sines and cosines of it, one of them will always come out nice, and the other one comes out to a decimal. That's just how this works. If the angle is a multiple of 30. One comes out nice, the other one doesn't. So, final answer would be 5.20, comma, 3. And I can actually check it doing something on the smartboard you can't really do on your notebook. So let's see if we can check it. I'm going to graph the point 6 pi over 6. What did we say pi over 6 was again? 30. So I'm going to go 1, 2, 3, 4, 5, 6, 30, and put a dot here. Does everybody agree? I'm making it bigger so we can see it better. Does everybody agree that that's correctly graphed?
Yeah.
Okay. Now, what I'm going to do is I'm going to leave that dot right where it is, and I'm going to change the background behind it to a rectangular grid that uses the same scale as this one. So if we've done it correctly, because the size, the scaling is the same, it should look like the dot is a little bit more than 5 units right, and exactly 3 units up. Okay, let's see. So let me just get my graph paper. Backgrounds. This is considered, what scale is this? I think this is large scale. So I'm going to use, that's large polar scale. I'm going to change it to large rectangular scale. And we're going to look for 5 units right. Well, 5.2, so a little more than 5 right, and exactly 3 up. Let's see. How's that look? Huh? Hey? I wait all year to do that. It's the best. It's the best. So there you are, polar. 6 units right. Rotate 30 degrees. Change it to rectangular. Go 5.2 right and exactly 3 up. So that proves it's right. You couldn't do that if you didn't have the same scale graph. But that is the same scale, so I can do it. Any questions on that? Let's finish up with this one. Now, is 120 a multiple of 30?
Yeah.
Yeah. So I told you, when you have a multiple of 30, one of these numbers comes out nice. Which one depends. And the other one doesn't come out nice. What's my formula to find x? Filling in those two numbers. So we get -4 cosine 120. We'll worry about that in a second. And what's my formula to find y?
Same thing about the sign.
Same thing with sine. Alright, let's do the first one. -4 cosine 120. Okay, that one did not come out nice. We got -3.26. Oh, I'm not in degrees, that's right. Why did I change to radians? Oh, the last problem is in radians. Thank you. Okay, I thought it should come out nice. So yeah, that one comes out nice. So we get 2. So what does that mean about the bottom one? That one's not going to come out nice. -4 sine 120. -3.46. So the way you could write your answer as a decimal is this. Now, you might not see a decimal on the test. You might see something different. What was the bottom one? Sine 120. Sine 120. Okay. So on test, you might see that that decimal value is written like this. 2, comma, okay. Let's see it like that. And if you type in -2 square root of 3, -3.46. That's exactly what we got as a decimal. You don't have to know how to write it like this. But if you saw this as an answer on the test, and you wanted to figure out, wait a minute, I don't know if that matches my answer, all you have to do is take the number they give you on the test, type it in on the calculator, and again, this would be if it was multiple choice, and change what they give you to a decimal. If you change that to a decimal, then you should be able to match it up with your decimal. That's how you can do it. Is there any question on that? You won't have to write this on your own, but you might see it in a multiple choice answer. So if I saw it, first thing I would do is just change everything that has a square root in it to a decimal. So that when I do my answer, my decimal matches that decimal. And then I know that that's correct. Hey, you want to see the grid one more time? Put the point, change it behind it. It's like amazing. I do. All right. So we got -4, 120. Do I have a big enough? Do I have that many rings on there? Oh, that's too small. That's the wrong scale. That's the one. All right. So -4. That means I'm going to go which way? 1, 2, 3, 4. -4. Did it say 120 or -120? 120. So 120, I'm going to rotate which way? Counterclockwise. Well, if I go to here, how much is that? 90. So I need to go right there. Okay, so that's my point. -4, 120. When I change the background behind it, it should look like it's at exactly 2 units right, and we'll say 3.5 units down. All right, let's see. Let me make it so you can see the whole thing. Oh, there it is. So, what did I say? 2 units right, 3.5 units down? Oh, let's see. Yeah? Never gets old. I do that at home, you know, I just have fun. I'm just kidding. So, 2 units right, 3.5 units down. Perfect. That's right where it should have been. So, rectangular, polar. Any questions on that one? All right. So that's the homework for tonight. 12 to 26 and 40 to 46. Just the evens. And tomorrow we'll finish what's left in section 5.1 and we'll start appendix 4 in the back of the book.